Okay, so good morning, class. So now, looking at the attendance for today, we are 58 students in class today. So note it, anybody that come now, I'm not going to accept that person. So it's going to be minus you, being the rep, because it's 58. So let's start the class. Now, last time we talked about monoterpenoids, talk about the monocyclic, acyclic, and cyclic. We'll talk about bicyclic. Okay. Now, in today's class, we're going to start with properties of monoterpenoid. Now, we'll also talk about the isoprene units as the moiety for terpenoids. And we say terpenoid when they're oxygenated, they are terpenoid. Without oxygen, they are terpenes. So if, for example, say terpene, it means that anything menthol is not a terpene. But if exam is asking for terpenoid, it means both terpenes, non-oxygenated and oxygenated, are graded because terpenoid is much more encompassing. So we'll be talking about the physical properties of these monoterpenes or monoterpenoids. Now, because they are essential oils, from the knowledge you know about essential oils, they are mostly liquid, okay? The few ones that we have that are solid are simple. The simple one you know is camphor. Normal camphor you see in the markets. I will normally use to deodorize or to fight cockroaches. That's a typical example of the one that is solid. Other ones are liquid. Okay. When you talk about liquid, talk about their melting point. Every liquid will not have any melting point because they're already liquid. So their melting point is always negative. Okay. So when something have a melting point that is positive, you think that thing is solid. It's very thick solid. Thick solid might have a very low negative. But every liquid are meant to have negative melting point because they're already negative. But their boiling point, they can have a boiling point, but they cannot, that will be positive, but their melting points will be negative because even water. Who is disturbing my class? Ola, please, Gideon, you're meant to control this class. Anybody that disturbs, you just remove the person. Okay, let's continue. I don't like distraction. Just have 1 hour, so we need to optimize the 1 hour. Distraction will make us to waste our time. I don't want us. Okay, so I was talking about physical properties of monoterpenes. Okay, remember we have cyclic, acyclic, and we have bicyclic. Now, in terms of boiling points, like alpha-pinene, remember alpha-pinene is non-oxygenated. So that's why they're very liquid. Their boiling point is high, 156. Nerolidol has a higher boiling point. But virtually their pressure is the same. Then in terms of solubility, every monoterpene, like essential oil, they are soluble in organic solvent. They can only dissolve in organic solvents. And are not soluble in water. In terms of essential oil, whenever I want to extract essential oil, it's always collected over hexene, meaning that hexene will dissolve it. Okay, so even something like alcohol can dissolve oil, but anything water, oil will always float. So if you've noticed that when you want to use your something like tea tree or eucalyptus oil in your water, when you pour it inside that water, it floats. You still feel the menthol, but it's going to float. If you put something like aboniki there, it's going to float. Okay, so talking about the components that are non-polar. Okay. Okay, you can see the structure of camphor. is oxygenated. So if you're talking about oxygenated, camphor is a typical example. And camphor, my question, these terpenes, are they mono or bi? Somebody should answer me. This alpha pinene and camphor, are they supposed to be under mono or di?
They are di.
They are di too. Good. Because if you bi, there's nothing like bi. We have di. Okay. It is bi, di, di. Okay. Meaning that they have two isoprene units. So it means that their carbon skeleton should be carbon number 10. All right. But it's very good for you to participate. It's better. So always participate. Okay. Even if when you get it wrong, the participation makes you a hero. And whatever you get wrong and you're corrected, you will never fail it again. So the occurrence of these monoterpenes, like I said, they're always found in plants and animals, both even marine. Talk about marine. In that marine, we have so many drugs that are in marine, including the animals in the marine. So both of them, both terrestrial and marine, are included, both plants and animal. And now in higher plants, that's in plant kingdom, they are distributed in higher plants like the roots, the stem, foliage, seed. Any seed has both carrier oil and essential oil. Difference between the two is that essential oil is essential component. That's what gives the oil the aroma. Why normal oil, crude oil, is not essential. Something then when you leave essential oils, you see everywhere will be smelly because it evaporates. Okay, unlike the crude one. That's why we use crude one as carrier oil that can help to dilute essential oil. So whenever you're cooking your lemongrass, the smell you hear is essential oil. In meat, whenever you're cooking ogufe, that's goat meat, that smell is essential oil of that goat meat. So essential oil is the aroma that can, even human being have essential oil. That the smell, that's a human being have smell. So anything that have smell have essential oil. Some smell are bad. Essential oil is not composed, it must be a very good aroma. Okay, so but they are very potent and they're medicinal. Okay, we can also get essential oil in softwood and hardwood. At times, if you go to timber side, you start hearing the smell that come from the wood. These are essential oils. They are responsible for the odor that this wood exhibits. Okay, we hear from insects that some insects you will kill, the smell will be so awful. That smell is essential oil, despite that it's awful. Okay, now in animal kingdom, these essential oil are used by insects as warning compound or a compound they use to attract. Okay, either they warn or they, like alligator. Alligator is warning. That's something like butterfly. Is the essential oil is to attract. That's why we'll talk about pollination. Okay, that volatile compounds are these are released. These monoterpenes are volatile compounds. When I mean volatile, it's something that can easily evaporate. They are always commercialable. So it's something that if you said, oh, I want to go into the business of selling essential oil, is a doable thing, but you have to look for the equipment and decide the method you want to use for your essential oil extraction. In a place in the Western world, that's why we have it, but send it down to us because every equipment is available for commercial purpose of essential oil. Like we have so many plants. Whenever you're passing through the street of Lagos, see people how we waste money. Plants, they cut it out and let it waste away. Those plants can be turned into money if we have facilities. Let's continue. Now, we are going to talk about how can this camphor be synthesized, the synthesis of camphor. Now, for us to synthesize camphor, our starting material is alpha pinene. Please, whenever you're asked to synthesize, understand, whenever you're studying this, each step, the reaction determines the product, okay? Each steps all the way. If I'm talking about this will give me this. So whenever you talk about reagent, also talk about, understand where the reaction is occurring. Okay, so that some of us, when you memorize, when you cram, instead of memorizing, you can come and mess everything up because you don't understand it. So before you start cramming, okay, I would advise you not to cram, either memorize or understand the mechanism, understand the reaction. If I talk about hydrated titanium oxide at the high temperature of 180, ask yourself what happened, what changed from this alpha pinene to campheine? What is the change? If you look at anything that changed, is simply my double bond. Okay, there is a movement of double bond. My double bond moved, which affected nothing. There was no addition, but just that my double bond. Okay, my double bond changes CH3 into CH2. So meaning that hydrogen should be then will be lost, right? So that's what I did. I ended up doing. So I moved from alpha pinene to campheine. Then when I want to add acetic acid, right, in the presence of an acid, what is happening? I'm forming an ester. So virtually it's a sort of esterification reaction, right, that an ester is being formed. Okay, then we form isobamyl ethanoate, which is an ester. This isobamyl ethanoate, under hydrolysis, I'm going to form isobamyl, meaning that, remember, whenever esters are hydrolyzed, they're going to form, normally esterification is acid and alcohol. So by hydrolysis, there is cleavage of bond, and they also give birth to their respective stuff. So by this hydrolysis, this carboxylic ring is being lead us not into temptation, please. I don't want distraction. So when under hydrolysis, there's a cleavage of bond. Virtually, if I'm like esterification, the reversible reaction is hydrolysis. Because when you esterify, you're going to get ester and water. And when you hydrolyze, like that water from the as a byproduct is going back into the system to form the initial reactant. That's why we're having isobamyl, which is an alcohol, okay, which under oxidation forms my camphor. Virtually camphor, if you look at the structure, the previous slide, okay, where we have camphor, you look at this camphor and look at this alpha pinene, you know there is so many things in common. Okay, the difference, what we can see extensively that is very different is the double bond changing to ketone functional group. Every other thing is still the same. And another thing is because of the rearrangement, the structure changes, but it's still the same carbon skeleton. Okay, so that is why we ended up in oxidation to form our camphor. How many steps do we have here? The first one is using titanium hydroxide, okay, to form campheine. Second one is esterification to form isobamyl ethanoate, which under hydrolysis will form isobamyl, and which oxidizes to camphor. Look at it and see if it makes sense. And let me see if you have question on this. Synthesis of camphor is something you should be able to reproduce. Like I said, understand what happened here. If you look at this structure, the methylene is not touched. The reaction site is that double bond. Remember, double functional group is that aspect of a compound that is very active. So anything that is saturated is not functional. The only reaction of saturated compound is what? Substitution reaction. So because we have double bond, that double bond is the most reactive section of this compound. So virtually every reaction that occur around this double bond. Okay? So let's continue. Now, Pulegon is a ketone, right? My question now, this pulegon, is it mono or bicyclic? I'm even asking you a question that is already there, but yet nobody's answering me. Whenever you see a compound, what you need to calculate the number of carbon skeleton. That's what will give you whether it is mono or bi. Okay? Okay. Monocyclic is going to have 10 carbon skeleton, okay? Monocyclic. As long as it's monoterpenoid, that mono means that I have only one ring and it's 10 carbon. Bicyclic is that I have 2 rings, but the total of that 2 rings is still carbon 10. As long as it's monoterpenoid, the maximum number, the number must be carbon 10. That is 2 isoprene units for you to be mono. Okay, so bi and acyclic is talking about these 10 carbon are not in a closed ring, while monoterpenoid is saying that these 10 are in a closed ring. Then we talk about bicyclic, where you have this in 2 rings. Okay, so it might be the cyclic can be anyhow. There's no standard of that. Now, so this polygon can be hydrogenated. When I hydrogenate my polygon, so okay, we have polygon under hydrogenation using hydrogen and palladium, carbonated palladium as a catalyst. So we're going to have cis dihydropolygon or trans. So we're going to have 2 isomers, okay? So when I'm going to enolise, enolization and equilibration of this cis and trans dihydropolygon is what we have under. So I can equalize them. When you want to equalize, okay, so I can move from cis to trans. I can also move from trans to cis. Remember, equilibrium is always a reversible reaction. So this is what we talk about enolization and equilibration of these isomers of polygon. Okay. So we're going to, what do we use in this? We're going to use potassium carbonate and ethanol in achieving our enolization equilibration of the isomer. So question here may be asking you how the reaction and enolization equilibration of polygon. So meaning that I'm going to do the first step, which is hydrogenation, before I do my enolization equilibration. So understand the topic, the question, and understand what to do. And remember, it's not compulsory that the question must go the way I just said it. But just understand that whenever I'm talking about the reactions of polygon, I'm talking about hydrogenation reaction. It's going to form 2 isomers. And whenever I'm talking about enolization equilibration, I'm talking about using potassium carbonate in the place of ethanol. Equilibration means there must be a sign of equilibrium where my cis can be transformed to trans. Somebody can remind me of this reaction. Where did you do this reaction? Gideon. Is Gideon in the class? Is Gideon not in the class?
Plasma.
Hey, Gideon suddenly become silent. Answer my question, John. That slide, which course did you hear something like that? You're muted. Answer me.
CHM 322.
322. Is it just 322? Are you sure 322?
Hmm.
Who else can answer me? The first time you heard about
It's
this.
actually 213, man. This is oxidation of primary alcohol to give.
God bless you. Who answered my question? See, in this class, as class will be going on, who answered my question? I'll be giving free Kenny for people that answer question. So
I
don't
did,
feel
ma'am.
that oh, please unmute. Let me hear you.
Yeah, I answered the question.
Oh, Daniel, I'm not
Yes, ma'am.
surprised. Thank you very much. So just even if I give you the mark, I don't think you need it. You gave me assignment the last exam. Thank you very much. Yeah, this is oxidation reaction using pyridinium chlorochromate, PCC. It was in 213 that we did this. where we are talking about that PCC has limited oxidation capacity. It cannot form an acid. Normal primary alcohol is meant to form carboxylic acid. But when I'm aiming at limited oxidation, I use PCC. PCC is going to limit my oxidation to aldehyde. It cannot proceed to carboxylic acid. So this is what we're talking about here. Okay. Now, the compound here is an essential oil from rose oil. And both citronellol and citronellal, they are all essential oil. And some of these are the reactions that occur in the system naturally. Now, remember, this can happen even when this citronellol, when it's exposed, it can trap oxygen from the atmosphere. But when I want to do this in the lab, I want to do oxidation to form my citronellal. I'm going to use PCC. Now we are done with monoterpenes or monoterpenoids. So we're going to the second one, which is sesquiterpenes. So how many isoprene units do we have in sesquiterpenes? How many please omit an answer. There is a free marks going on. So if you don't answer me, please, you're not interested in this class. This class is supposed to be a class where we do. Can I hear you?
3 ma.
3 isoprene units. Thank you. Who answered my question?
I'm the one, ma.
Is it Daniel? Okay, Oyetunde Shola. Please, anybody that answers question at the end of the class, just remind me, okay? Just be telling me how many questions you've answered. When we finish this 435, come and remind me. At least I have your names in my subconscious, but come and remind me. So that when results come out and you have issue, those marks, okay, that you're accumulating in class will be used for your favor. Okay, so let's continue. So sesquiterpene, like we said, these are volatile compounds that are isolated by steam distillation. So being isolated by steam distillation, what does it mean to you? When you say we are using steam to distill it, there's one word that will come to your mind. Who can tell me what you think about if they said steam distillation can work on this? So what will come to your mind? Let's talk now. Whenever I want to think about extraction, what am I supposed to consider?
Solvent, ma.
I need more answer. If I want to do extraction of my plants, what am I supposed to consider? Number one, is it my solvent, the solvent I want to use, because solvent will determine the extraction method. Number two, at times, it's not everything in the slide that you're going to ask. Some of the things you ask in the class is to understand your capacity. So don't say, this is not on the slide. When you see it in the exam and say, that's the sense of knowing people that are in the class. There's some things that might not be in the class, in the slide, that can be prompted. As we are discussing now, it will come up. So if you see it on the day of exam, don't say, this one she did not teach us, it's not in our slide. So that's where we know people that don't come to class. So any idea, which other thing are you supposed to consider?
My temperature.
Temperature, yes. Why do we who is answering whenever I do, don't forget, you have to remind me of your name that you answer question. So what's for temperature? Why do you need to consider temperature?
Ma, because there are some plants that cannot withstand heat.
Yes, because there's some metabolites that are heat sensitive. So that's all. Now, So with this now, using steam distillation for sesquiterpenes. So what message are you getting from that particular thing? What message? Now, when we are talking about something using steam to distill, it means that the sensitivity is not as that of monoterpenes. Okay, they can withstand heat more than monoterpenes. Okay, and they are mostly found in most plants and fungi, but they are very minor. Monoterpenes are much more than sesquiterpenes. They are everywhere, but that's the aroma. Okay, example of sesquiterpenes, we have phenacin, we have gamma monoline, we have mansonon C. So if you look at them, when we calculate so phenacin is a cyclic sesquiterpene, while the other two are cyclic sesquiterpenes. So meaning that my sesquiterpene can also have a cyclic. Okay. All right, having said that, these other examples, phenacin and phenesol. Let's go back to the previous slide. This is phenacin, this is phenesol. The difference between them is the one is non-oxygenated, other one is oxygenated. Okay. And we also have carophyllene. Carophyllene is a powerful component that is very potent, and some of these essential oils are ones that are very unique, just like talking about limonene. When you talk about limonene, this is active of lemon or lime. It's the presence of limonene that makes lime or lemon very potent. This limonene can work synergistically with other essential oil, okay, inside the lemon. But the most important thing that brings that smell your ear is receiving from lemon peel is limonene. Okay, we also have with the small, we have linderine and others, as you can see on the slide. These are all sesquiterpene. From this sesquiterpene, you can see that the ones that are acyclic are mainly phenacin and phenesol. So if you're asked about acyclic sesquiterpene, if you know phenacin, you should be able to predict phenesol. But the difference is just oxygenated and non-oxygenated. So I should be able to also predict the structure of this carophyllene some way, somehow. I don't know why I like it. Okay, I'm not saying that it's going to be part of what you're going to be asked in the exam. You just wait. You see carophyllene, even from the name, lean, meaning that in it is non-oxygenated, all oxygenated. So from the name, you can actually know the one that are oxygenated and non-oxygenated. Why is sesquiterpenes essential? Why do we need them? These sesquiterpenes, they have benefit, which is allelopathy, phytoalexin, and phytotoxin. When you talk about, a question might be asked, what do you understand by allelopathy role of sesquiterpene? Meaning, there are some plants that when you plant that plant, the plant will destroy other plants. So these plants, the thing that are causing the problem is the component of this plant, which is sesquiterpene. Sesquiterpenes are used to control other plants in deleterious fashion. So if I don't want plants, there's some plant that when you plant them, no other plants can grow in that place. Even the ones that are grown are going to die. So because of the presence of sesquiterpenes, they also have antibacterial properties. We call them phytoalexin. So phytoalexin potential of sesquiterpene is useful as antibacterial agents, while phytotoxin is useful as antifungal. Okay, used by fungi to break down plants. Okay, then defensive chemicals used by plants against insects and fungi. There are some plants that will never, there are some plants that you cannot see insects around them. And there are another plant that you can see insects, even building houses around them. So those ones that insects are always running away. You cannot see something like spoilage around them, like fungi. They cannot be fungi growth. It's because these plants have enough sesquiterpenes. So the plant naturally use sesquiterpenes to ward off enemies like ants and fungi. Okay, so this role of sesquiterpene is every essential oil or every phytochemicals that are used as plants for defense, okay, and for protection, and then used by animals like us, man, for healing. So that's why both plants and animal are enjoying, just like CO2. CO2 is beneficial to man and also beneficial to animal, because when beneficial to plants, because to man is a waste product, to animal, to plants is a a starting material. So the waste product of plants is healthy for man, while the waste product of man is a starting material for plants. So that's thread by butter. Nature has provided thread by butter everywhere, even in terms of weather. When there is sun, there is rain, they balance themselves. So we've known the benefits of sesquiterpene as the major three: allelopathy, phytoalexin, and phytotoxin, and also as a defense mechanism against predators as insects and fungi. Okay, so there is this compound. This particular compound, if you look at the slide, how do we elucidate? When you talk about structural elucidation, what comes to your mind? What comes to your mind? When you're told to elucidate a compound, it simply means what are the reactions that will confirm the functional group in this compound. So when you're given a compound like this, the major thing that we can do in elucidation is what? Number one is we can do hydrogenation, okay, because of the presence of double bond. We can also do oxidation because of the presence of the double bond, right? When you oxidize, remember in station 213, we can form aldehyde, we can form ketone, we can also form CO2 and water, depending on the nature of the double bond. So the same thing is obtainable here. So this is beta-catenin. So using this beta-catenin, we are trying to elucidate. Let's go to the next slide. Oh, that's not it. Okay. Okay, now let's talk about structural elucidation of beta-catenin. Beta-catenin can be structurally elucidated because they are either double bond isomers or tricyclic compound belonging to a class of sesquiterpenes. Looking at the structure, we talk about the nature of the skeleton. If you do the hydrogenation of beta-catenin with sulfur, we're going to get catenin. When we do hydrogenation, dehydrogenation, we're going to get what? Cadalin. And when we do position of the double bond, using UV spectra data, the molecules is going to tell us the presence of conjugation, which also is susceptible to ozonolysis. Okay, so like I said, whenever you want to elucidate a compound, look at the reaction that this compound can comfortably undergo to validate the functional group present in that compound. Okay, this slide is not meant for you to, is a complement the slide, but it's not meant for you to take serious. We're not going to dwell on that slide. So let's go to the next one. So this is the slide you're supposed to dwell on. Now, you remember we're talking about structural elucidation of this beta-catenin. Now, from this beta-catenin, we can also synthesize other compounds. We can synthesize other compounds because it can react with the acid, either 1 mole or 2 mole. We're going to end the class here. So listen very well because I'm going to take my time. Now, the compound I'm going to synthesize using beta-catenin, it depends on number of acid I'm going to use. Whether I'm using 1 mole or 2 mole. Then it will determine whether I'm going to form pyrometallic acid or I'm going to form 7-methyl-cadherin. Now, let's go. Let's follow the protocol. This is my beta-catenin. My beta-catenin has 2 double bonds that is not conjugated. Okay. Now, when I use my 1 mole of the acid, the presence of this acid is going to cause an epoxide to be formed with the double bond. So now, if I'm using 1 mole, I'm going to form 1 epoxide with either of the double bond. Right? If I use 2 mole of the acid, I'm going to form epoxide at both ends that bears the double bond. So the essence of my acid, the number will determine the product I'm looking for. So if even my product is a product that will be di-epoxide, so I'm going to use 2 mole. And if it's mono, I'm going to use just 1 mole. Okay. Then when I'm done forming my epoxide, then I'm going to further use methylated magnesium chloride. Okay. Then dehydrate and the presence of sulfur. Now, if I'm dealing with that epoxide formed from 1 mole of acid, I'm going to form 2-methyl-cadherin. Remember, the 2-methyl is from that place of epoxide. Now, depending also on the place I use, the double bond I'm using to form my epoxide. If my double bond is on carbon number 2, I'm going to form 2-methyl. What if my double bond is on carbon number 7? I'm going to form 7-methyl. Now, this is also, the same thing is still the same 1 mole of acid. But now the double bond I'm interested in is double bond on carbon number 7. So using my methylated magnesium chloride, dehydration and sulfur, I'm going to form 7-methyl-cadherin. Now, remember I said this is for 1 mole. So 1 mole can be, epoxide can form at carbon number 2, 2-epoxide or 7-epoxide. But when my interest is on 2 mole, the same process is still here, but instead of going 1 and 1, I'm doing everything at the same time. So I'm using 2 mole of acid. In that 2 mole of acid, I'm going to form both 2-epoxide and 7-epoxide. So when I use methylated magnesium chloride, dehydrate and add sulfur, I'm going to form both 2 and 7-dimethylcadherin. So that structure, there is something wrong with it. If you look at the structure of your 7 and structure of the 2, you realize that those 2 broken bonds, the one on the outside, one is inside, are meant to be on the position. One is naturally there, the other one is one with that epoxide added. So we're going to have 7-methyl because the other one is already part of the cadherin. So we have extra methyl added at carbon number 7 and methyl added at carbon number 2. That's why we have 2,7-dimethylcadherin. Now, whether I'm having 2,7 or I'm having 7 or I'm having 2, when they undergo oxidation using acidified chromic acid, my 2,7 is going to form my product, which is pyrometallic acid. And my 7-cadherin using nitric acid is also going to form that pyrometallic acid. Okay, so these are the methods. The question can be, how do you synthesize pyrometallic acid using 2 mole of per acid, or the synthesis of pyrometallic acid using 1 mole of per acid. So that's the question that I'll direct you on the route to follow. And the question can as well come out using 2 and 1 mole of pyrometallic acid, synthesize using 2 and 1 mole of cadmium, using 2 or 1 mole of per acids, 2 and 1 mole of per acid, synthesize pyrometallic acid from cadmium. Meaning that if I want to use 1 mole, either I use 2 or 7. I must not use the 2. So 1 mole and then 2 mole. So I'm going to also end up in metallic acid using the skin as shown. So that is how to answer this question. So we're going to do our classwork, ask question, where we move to our classwork. Some people did not come to, people that came late. If somebody just coming in, some people came late. Normally you're not here. At least I started this class by 8 minutes past 10. I said my lateness starts after 5 minutes past 10. So after 5 minutes past the number of the actual time of the class, you are late. And when you are late, it's assume that you're absent. Normally, this is an online class, so you cannot tell me that you're stuck on the road. And you cannot tell me that the bus did not full in time. Even if you're in a bus, you can use your earpiece and listen to the class. So nobody is exempted or will be exempted from coming to class anything later than 5 minutes past the actual time. Kamut, ask your question while we do our classwork. Any question?
I'm sorry, ma. Actually, I don't have question, ma. But I just want to request that we don't have this slide that you are using, ma.
Yes, I'm going to give you the slide. Normally, the essence is that after the class, I'll give you the slide. You know, we are going to be using, after this particular tapinoid, we're going to have another class. So we'll talk about, I think, flavonoid. So when I'm done with terpenoid, I will give you the slide of terpenoid before going to flavonoid. So
Okay, ma. Thank you, ma.
That's the method. Thank you. So let's do our classwork. Gideon. Is Gideon in the house? Daniel, can you help me take down the questions? Because Gideon is not responding to me. I don't know whether Gideon is having another business.
Okay, ma.
Gideon, when you come to school, just tell me the business you're doing. Because this action is telling me you're doing business.
Not doing anything. I'm replying, ma.
You're replying after how many minutes? You know, the bad thing about this online is that somebody can be doing something else and just log on.
I'm not doing something else.
And say later we'll just watch the recording. But it's fine. I want this thing to be now. Whenever we are taking down this question, please. After then, you're going to give me an MS Word. I don't want the one that I can just copy. I don't want the one I will start downloading and everything. So the one I can just copy and paste in the Google Classroom. So number 1 question. I'm going to be slow. Question is just what we did today. So number 1 question is, what can we talk about today? Okay. How can you synthesize camphor? Synthesis of a detailed synthesis. Using detailed equation, show the synthesis of camphor. Using detailed equation, show the synthesis of camphor. If it's taken, tell me it's taken.
Taking, ma.
I would have wanted to employ everyone. Don't just go and copy the slide. Try reading. That's why I'm going to give you guys till 11:59. So that try going through the slides. Try reading before answering. So you don't just go and copy the slide and submit. Because copying the slide does not make any difference. And when you read and try to answer the question on your own before submitting, you will understand what you know and what you don't know. I normally advise always start reading from the day lecture starts, so that when there is test or exam, you don't enter clash programs. Chemistry is not something you want to read and understand in 1 week and write the exam. When you enter the exam hall, you'll be confused because so many things will mobile up. But when you, the way we are doing it, one step at a time, if you are simulating along the way, when you were talking about exam, you're just going to revise, or test, you're going to revise. You'll not be putting your legs in water, drinking coffee, looking for cola to take. You're looking for energy drink to take. Those ones will even make you bitter. Because by the time you enter exam hall, your brain will not be at equilibrium. You end up not doing well. So let's be advised to start reading now, especially now that even lectures are not being bombarded. So number 2 question. Show the reaction and analyzation equilibration of polygon. Show the reaction and analyzation equilibration of polygon. That's number 1B. That's number 1B. If it's taken, say it's taken.
Taking,
Taken?
ma'am. Yes, ma'am.
Thank you. Okay. Now, if in the exam, I ask you a question that has to do with citrinellol, I don't expect anybody to fail it. The reactions of citrinellol. If I talk about the reactions of citrinellol, I don't expect anybody to fail it. Give as an exam and as an assignment, because it's something that you know very well about. So I'm not giving as an assignment. What are the roles of sesquiterpenes? The 3 roles or 3 benefits or 3 significance or 3 importance of sesquiterpenes. 3 benefits, 3 importance, 3 roles of sesquiterpenes. Okay. Give 2 examples of labeled sesquiterpene. Now, the first one, after 1A and 1B, this one I talk about the role of sesquiterpene is 1CI, then the structure is 1CII. What was the question 1B?
Show the reaction and analyzation equilibrium of polygon.
Okay, then this is number 1C now. Sesquiterpene, the role and 2 structures. So we're going to question number 2. Question number 2 says, how do you structurally elucidate beta-catenane? That's 2A. How do you structurally elucidate beta-catenane? Then 2B and the last. Using 1 mole and 2 mole of the acid, synthesize pyrometallic acid. Using 1 mole and 2 mole of the acid, synthesize pyrometallic acid. That is a question. That's a question for the class. So ask your questions. If you don't understand the question,
Sorry,
ask
ma.
your questions.
The last question again, ma.
Okay, using 1 mole and 2 mole of the acid, show the synthesis of pyrometallic acid. Is that taking?
Yes, ma. Thank you, ma.
Any question? Please, Gideon, help me to take attendance now. So many people have gone. Take another attendance now. Now that people are leaving, take attendance immediately. Now, just take 63 students are here. Before we know one who started it. And I want the exact name. So I want to know the people that left before I left. I leave the class. So those ones are even the worst culprits. So can you take attendance now? Just give a snapshot. What I need, I don't want people writing their names. Just give me a snapshot of the attendance on this Zoom. You can, even if it's the snap is 3 or 4 or 5 or 10, I don't care. Just give me their snapshot shots. Okay, that's how we'll be taking attendance. Don't write anything. I don't want anything. I want something evident. So I want something that will correlate with what I'm seeing now. And please make sure that your name is attached to your. If not, it means that you're not in class. When you go and use something, put your name, put matric number. Put your name and matric number. So we can link you up. Okay? Very, very important. This Zoom user, in the next class, I'm going to remove you from the class. Zoom user, I have to remove you from the class because it's as good as you not coming online by using Zoom user. So next class, when I see you, I will automatically remove you. So better go and edit your profile and put your name and let that be matric number. So people that had their names without matric number, I'll pardon you for today. I'll pardon you for the previous classes. But after now, you are as good as you don't have any mark for the attendance. Remember the way we do. Attendance have mark. And some of these little things are what matters on the day of reckoning. So don't take anything for granted. Okay, so thank you very, very much for being available for the class. I'm going to share the question on the Google Classroom. I'm going to give you time because I want you to go through the slides, study the slide before you do the assignment. Okay, so it will not make sense for you to just go and copy and paste. Oh, now I remembered what Daniel was saying, that you guys don't have the slide. So okay, I'm going to share the slide today. I'm going to share the slide with you because I want you to always study the slide. So I'm going to share the slide with you so that you can study the slide before you drop the assignment. Any question? Any question?